I think it's high time to start. So first of all, my apologies for any inconvenience about the time, but I'd like to start this webinar by saying good morning to you all and welcome to our webinar to mark Earth Day 2021. Thank you all for being here with us today, and thank you to Professor Fernando Lopes for joining us. So having said so, I'm now going to introduce our guest. Professor Fernando Lopes was born in Mozambique in 1966. He graduated in geology at the University of Coimbra, and he has a master's degree in physical sciences by the University of Lisbon. He concluded his PhD degree in geological engineering at the University of Coimbra in 2002. From 1990 to 1993, he was a teaching assistant and assistant between 1993 and 2002 in the Department of Earth Sciences of the Faculty of Sciences of the University of Coimbra. Since 2002, he has been an assistant professor in the same department. His main scientific areas of research include structural geology, tectonophysics, seismic stratigraphy, salt tectonics, geological hazards, and geosciences outreach. Professor Fernando Lopes has published papers in journals and in conference proceeding books. He has co-authored 11 book chapters, 3 of them on international editions, and has coordinated the edition of 11 books. He has also co-supervised 1 PhD thesis and 12 master dissertations. He is currently involved in 3 research projects, 1 national and the other 2 involving agreements with Brazil and Argentina. So, besides this successful and prolific academic career, today's guest and presenter is also an actor in a theater group and a keen painter, keen artist. Professor Fernando Lopes is a truly multifaceted person, and it is a true privilege to have him with us today. So on behalf of our eTwinning group, we would like to thank you, Professor, for having accepted teacher Matilda's invite to be with us here today. And without further ado, Professor, the stage is yours.
Thank you very much for the words. Thank you very much for the invitation. It's for me a pleasure to be here with you and to speak a little about the Earth and the paper of the geologist in the world. I choose this presentation to be a geologist. I hope you enjoy it. Okay. I think, okay.
Já está a partilhar.
Okay, thank you. Okay, the title of my presentation is to be a geologist. First of all, I would like to speak a little about the Earth and the geological process. The Earth is a dynamic planet where lithosphere, atmosphere, hydrosphere, and biosphere are linked by cycles. These cycles are driven by solar energy. They determine the climate, they influence the formation and the strain of the rocks, and they affect the living beings. Much of the Earth's surface is relatively new, having less than 100 million years. The oldest parts of the Earth's crust have up to 4,000 million years. Of all the telluric planets in the solar system, only Mars has some relief features similar to the Earth. Our atmosphere is composed by layers, troposphere, stratosphere, mesosphere, thermosphere, and exosphere. These layers and the linkage between them are responsible for the geodynamic, the external geodynamic. Our Earth, the interior of the Earth, are also composed by layers. We can find from the upper to the interior of the Earth a crust, upper mantle, external core, and internal core. These layers, the interaction between these layers is responsible for the internal geodynamics. Oops. Sorry. The upper portion of the Earth are composed by rocky plates, rocky fragments. Here in this slide, we can see the main lithospheric plates, the main rocky plates. These plates are not static; they move, they interact between them. The boundaries between the plates are the most geologically active places in the Earth. We can find here with arrows boundaries that are they converge, another one diverge, and we can find also boundaries that the plates moves laterally. But all of these boundaries are the most geologically active places in the Earth. So the internal process of the Earth have effects in the Earth's surfaces. So we can see from these effects the strain, the strain of the rocks. We can speak about earthquakes. We can speak about volcanism, faults, folds. All of these kind of features are caused by the internal process. Also, the atmospheric dynamic can create some external evidences like rock weathering, erosion, transport, and sedimentation of sediments. The Earth activity can be seen from the rocky cycle. In this kind of cycle, we can find the formation and the strain of the rocks, and the weathering and erosion of the rocks. So we can separate it in this rocky cycle. We can separate it sedimentary cycle, igneous cycle, and metamorphic cycle. The igneous cycle is the cycle that is responsible for the igneous rocks. We can speak about extrusive rocks. This kind of rocks are composed by microcrystals or by glasses. Lava and ashes are examples of this kind of rocks. And we can speak about intrusive rocks like granites or gabbros. So these kind of intrusive rocks are composed by large crystals, and the cooling of the magma is very slow. Examples of volcanic rocks, we can speak about rhyolites, andesites, enzites, and basalts. For the plutonic rocks or intrusive rocks, we can speak about granites, granodiorites, diorites, and gabbros. Geological resources associated to the igneous rocks. We have metallic resources like gold, silver, copper, wolfram, iron, aluminium, tin, zinc, lead, uranium. Non-metallic resources from igneous rocks. We can speak about ornamental rocks like gabbro, granite, jewelry, minerals like diamonds or emeralds. We can speak also about feldspar, quartz, sulfur, and rocky ore. These are the main igneous materials that are very important for our society. Let's speak now about sedimentary cycle. Sedimentary cycle is the cycle that are responsible for the formation of sedimentary rocks. We have the weathering and the erosion of the igneous or metamorphic rocks, or also old sedimentary rocks, and the fragments of this erosion are transported and are deposited in the places like sedimentary basins. And these fragments are transformed in sedimentary rocks after burial and lithification. Examples of sedimentary rocks, we can speak about detrical or clastic rocks. Examples: conglomerates, sandstones, mudstones, and also carbonatic rocks like limestones, dolomites, mudstones, travertino is a kind of limestone, and breccia. We have also geological resources associated to sedimentary rocks, like energy resources, coal, oil, and natural gas, and non-metallic resources like limestone and clays. We have also halite from salty mines. This kind of geological material is an evaporite material. We have also sulfur and potassium salt for industry. Sands for constructions, limestones for constructions and ornamentation. It's another kind of materials from sedimentary resources. Let's speak now about metamorphic rocks. Metamorphic rocks are rocks that are transformed from sedimentary or igneous rocks. We can speak about regional metamorphism and contact metamorphism. What is the difference? Regional metamorphism is the metamorphism that are caused by mountain buildings. When rocks are submitted to height, pressures, and temperature, normally these rocks are transformed in another kind of rocks. And this transformation is called metamorphism. When this metamorphism is caused by mountain buildings, we can speak about regional metamorphism. And we have the contact metamorphism. This kind of metamorphism are created by magma intrusions. When magma intruded in some kind of places in the Earth interior, the heat of the magma caused a transformation of the rocks in the boundary of the magma. So this transformation created a contact metamorphic rock. Some examples of regional metamorphic rocks: gneisses, schists, marble, quartzites, and serpentinites. Some kind of contact metamorphic rocks. We can speak about skarns and hornfels. Geological research associated to the metamorphic rocks. We can speak about jewelry minerals like rubies or sapphires, talc for the cosmetic in the industry, asbestos for thermal isolations, and marbles for constructions. The geological processes created other geological events like earthquakes, like volcanoes, landslides, floods, etc. So this slide, or in this slide, we can see the distribution of the seismicity in the Earth's surfaces. So we can see that the most of the epicenters of the earthquakes are concentrated in the tectonic boundaries. So, like I said, the boundaries are the most geological active places in the Earth. Volcanoes are another hazard geological effects of the internal process of Earth, and also the most volcanic centers are located in the plate boundaries. Tsunamis are caused by water perturbation. Tsunamis are caused by earthquakes or by volcanoes or by impact or cosmic impacts. So we can find in this kind of events geological hazards also. Landslides and avalanches, floods, coastal erosion, and cosmic impacts. This is some examples of geological hazards. So, geologists. Geology, from the Greek geo, geo is the earth, and logos, reason. Geology is the science that studies the earth materials that constitute the earth and the process that lead to its formation and modification over geological times. A geologist is a scientist that who study the materials that make up the Earth and the process that conducted to its formation and the formation over the geological times. Some skills needed to be a geologist. Excellent analytical skills, excellent communication skills, ability to understand the basic engineering principles, passion about the geological and natural environment, mapping techniques, flexibility and stability, enthusiasm, patience and perseverance, ability to work with teams of people from a wide range of backgrounds, and good physical fitness. Some tools for the works of a geologist. Direct observation in the field observation. It's very important. We need to work with maps, geological maps, topographic maps. We need to work with some tools like compasses, hammers, a notebook. It's kind of materials for geological annotations and take some pictures and samples. Observation and characterization of outgroups. It's very important in our work. Sampling of rocks, waters, sediments, and soils are another kind of things that is very important to do in the field work. Analysis and interpretation of geological maps, satellite images, and aerial photography are also some kind of works that is necessary to do in an analysis and characterizations of the geological features. Sorry. Laboratory work for chemistry analysis of rocks, sediments, soils, and water is another thing that is necessary to do. Laboratory work for petrographic analysis, macro and micro analysis of rocks and minerals. Laboratory work for mechanical analysis of rocks, drill survey, geophysical survey of subsurfaces, and all of these things are very important for the geologist works. So we can find in geology some kind of branch and areas of study. So geology, it's a big area, and we can find two groups, scientific geology and an applied geology. For scientific geology, we can speak about physical geology and the historical geology. Physical geology is the group of geology that study the geodynamics of the Earth, the external geodynamics and the internal geodynamics. The historical geology is geology that study the stratigraphy, the paleontology, and the paleogeography. The applied geology it's the geology that can be work with the society directly. We can speak about economic geology and the engineering geology. The economic geology, we can prospect it and try to find mineral resources, energy resources, and hydrological resources. For the engineering geology, this is the geology that work with engineering aspects like constructions, projects for dams, for roads, and also the environmental aspects of the society. So some areas in the physical geology: sedimentology, geomorphology, structural geology, petrology, mineralogy, and volcanology. For the applied geology, we can speak about metallic minerals, non-metallic minerals, fossil fuels, and geothermal activities. Oh, sorry. I have a problem here. Okay.
Professor,
Scientific
allow me to interrupt you, Professor. We have about 5 minutes.
Okay.
Thank you very much.
Okay, thank you. Paleontology, sedimentology and stratigraphy, structural geology, geomorphology, in the scientific geology. And, oh, sorry. Okay. Petrology, mineralogy, and crystallography, paleogeography, volcanology. And for applied geology, we can speak about energy resources, environment, mining, and engineering for constructions, for infrastructures like dams, foundations, tunnels, roads, landfills, etc. So, for an example, the impact of mining in our lives. If you see every day we contact with geological materials, okay? For example, our phones. This is a kind of thing that it's necessary to have geological materials, quartz, some minerals very important, like quartz is another kind of material, copper also. In our houses, bricks, glasses, computer monitor, etc. This kind of things are things that needed some geological materials. So geological resources, geological events are also things that this human society needed to understand and study for better understanding the Earth. So for the society, the geology, it's a big area of the knowledge that are very important, and I think we need more people that like geology, and we need more geologists. So I hope you that are are study sciences. I hope that you like to study geology, and in the future I would like to find from you some geologists, a new geologist.
Only the future will tell us, Professor.
Okay.
I don't think we have much time for questioning. Would you be available for later questions, even if they were in written form, Professor?
Okay. Yes,
thank you
of
very
course.
much.
Yes, of course.
So
yes, of
I
course.
believe, okay, thank you. I believe we have to finish. And I'd like to thank you very much for your educational and insightful approach to what it means to be a geologist and what it involves. So I don't know if there are any further comments, but I think we have to finish right now before it stops us. Professor, would you like to add anything?
Okay, thank you very much for your invitation, and I see you in another time for another conversation. Thank you very much, and good luck for you.
Thank you very much on behalf of our eTwinning project. Thank you for your availability, Professor. Goodbye.
Thank
you.
you.
Thank you. Goodbye.
Bye-bye.
Bye-bye. Thank you.
Bye-bye. See you.
Obrigado, Sr. Fernando.
Okay.
Thanks.
Okay. Um abraço.
Bye-bye.
Goodbye. Bye. Hello. Goodbye.
Hello. Bye-bye.
Bye.
Bye-bye. Bye-bye.
Bye. Goodbye.
Thank you.
Goodbye.
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 Ai, caramba.
I'm sorry for the drawings.
No.
Eu gostava de
No
aprender.
problem, no problem.
Eu gostava sinceramente de aprender como é que os pequenos fazem isto. Eu não
Sabem
faço
mais
ideia,
do
mas
que nós.
eles fazem sempre isto. Eu não faço ideia como, mas eu gostava de aprender como é que os gajos fazem aquelas coisas.
Pá,
Pelo menos